Okay, in this video, I'm going to explain how to do a certain kind of weighted average problem that is shown up on the GMAT. And so we have 7 pieces of rope that have an average length of 68 centimeters. And so in general, when you read a question and you're given the average and the number of items, you should immediately convert that to a sum. So our sum formula is sum equal average times n. And then, so in this case, we're given the average length is 68, and the number of items is 7, number of ropes. So the sum of the lengths will be 68 times 7, which is 476. If you do 7 times 8, 56, but the 6 here carried a 5 over. 7 times 6, 42 plus 5, 47, so 476. And then what we're also told is that we have a median of, the question said the median length is 84 centimeters. Okay, so I'm going to write the sum down, and then I'll represent the numbers on a number line. So we're told that our sum is 476 in effect. Okay, so 68 times 7, 476. And then we can represent the 7 pieces of rope on a number line as follows. So the first piece would be A, B, C, D, E, F, and the last one will be G. So I can represent them as follows: A, B, C, D, E, F, G. Now we're told that the median length of these ropes is 84 centimeters, meaning that D is 84 centimeters. And then we're also told that the length of the longest piece of rope, so the longest piece of rope is 14 centimeters, more than 4 times the length of the shortest. If they are arranged in order, this is just telling us the G equal 14 plus 4A. Okay, and we're trying to maximize G. The question is asking us, what's the maximum possible value of the longest piece of rope? If we want to maximize G, then we must make the other values as small as possible, because the sum is fixed. So in order for G to get bigger, it must take some from the other ones. Well, we have a median of 84, so how small can we make E and F? Well, they can be as small as D, and the median will not change. But if they're any smaller, the median will not be 84. So the smallest E and F can be will be 84. They are not distinct values. The question did not say that. Otherwise, we might have had to make E 85 and F 86. But since there's no restriction that they are distinct, E can be as small as the median 84 and stay in 5 to F. And then because there's a restriction, our relationship between G and A, we cannot make A 1, because that would make G 14 plus 4, 18, but that's not the largest. So A has to be some value. We just don't know what it is, so we just let it be A for now. And B, on the other hand, how small can B be? Well, it can be as small as A. And the same thing goes for C. So we can say, if we add all these numbers up, there are 3 A's here and there's 4A here. So this is 7A. We have 7 A's if we add all the numbers up. And then there's a 14 plus 84 times 3. This should be equal to 476. And so if we simplify, we'll find that what we have is 7A plus, well, 84 times 3 is 252, plus 14 is 266. This is equal to 476. And then we can solve for A from here. So 476 minus 266 is 210, so 7A equal 210, which means that A equals 30. Well, we're looking for the value of G, not A. So we have to plug A into the expression for G, 14 plus 4A. So this is 120 plus 14, or 134. So G is 134. This is answer choice D. Okay, so I hope that process makes sense. You just have to set up variables for representing each length of rope, and then decide how you're going to minimize each of the lengths except the longest piece of rope's length, G, and then equate the sum to 476 and solve for the missing variable, and then plug back in. Don't forget to plug back into the expression for G to get us the longest possible value of G. All right, so I hope that makes sense, and I hope you enjoyed the video. I'm going to be posting more videos, so keep watching, and I will be posting additional videos on different topics.